Hey, in today's video, we're gonna go over vector components. Vector components are something pretty easy to understand. So let me show you. Let's say we have this vector right here. We're going to call it V. And we have a magnitude for this vector that is going to be 4 newtons and a direction of 60 degrees. Now, something you need to know. If you're going to play with vectors, you need to go to the world of graphs and some trigonometry. So first of all, to find the vector components of this vector, we need to draw a graph. Or, well, it's not a graph, but it's going to be, I'm going to show you. It's basically a drawing. We have this. Okay, these are just going to be our axes. This is x and this is y. Now, to draw a vector, what you're going to do is you're going to draw a line that is going to have a length of the magnitude of the vector. So for example, if we have a magnitude of 4 newtons, that means that we're going to draw a line that is 4 units long, okay? So let's say something like this. And now, what about the angle? Well, with the angle, you need to make sure that the angle that you're given is going to represent the direction of the vector with respect to the x-axis. So that means that if you have 60 degrees, you want to make sure that between the x-axis and the line that you drew, you're going to have an angle of, in this case, in this example, 60 degrees, okay? For any degrees that you have, you want to make sure that the line has that number of degrees with respect to the horizontal axis, okay? Now, this is basically a vector, okay? And we just simply, we drew this vector in a xy plane. Now, how do we find its vector components? Well, there is something that I want to show you. If you draw a line like this is going to be, you could say, the side of a right triangle. Okay? If I make this a square right there, now you might see how there's a right triangle right there. You have a side, which, let's say we're going to have a side that goes something like this. Okay, this is going to be like the horizontal side. I'm actually going to draw it down here. We have something like this. We could say this is going to be our side V and this is going to be our side A. And this is the hypotenuse. I hope you see the resemblance. We have side B, this is going to be side B, and A, this is going to be side A. Now these sides B and A are going to be the vector components for this vector V, okay? Just if you, don't see it like only in this triangle that we have down here, but if you can bring this shape up there, these two sides, A and B, are going to be the vector components. Now, what does that mean more mathematically or more numerically? Well, if we have a vector that we represent with the letter V, we could write this side V as Vy, okay? Because this side, or how this vector projects in the y-axis, is going to be a amount that we can call it Vy, okay? And we say it's going to be y because, well, it's parallel to the y-axis. And now this side, which would be A, we're going to say it is Vx, okay? Because this vector is projecting Vx units to the x-axis, or on the x-axis. That's actually correct. So now, how do we find Vx and Vy? Well, we have an angle, and remember that we also have the length of this line. That would be like our hypotenuse. We know this is just simply 4, okay? Now, if we have an angle and the length of the hypotenuse, how do we find the two sides? Well, that's pretty simple. Let's just do some algebra and some Pythagorean theorem too. So, let's go first down here. If we have this side, okay, which I'm going to call alpha, then you could say, for example, that the sine of alpha, remember, is going to be the opposite side, which is b, over the hypotenuse. And then you could say that v is equal to h times the sine of alpha. And now what about for a? Well, then for a, you could say that you have cosine of alpha is going to be equal to a over h. Remember, cosine is equal to the adjacent side divided by the hypotenuse. And this is the same thing. A is going to be equal to h times sine of alpha, okay? Cosine of alpha, I'm sorry, this is not sine, yeah. Cosine of alpha. Now, if you follow this line of reasoning and these equations, you just found the vector components for v, okay? So now let's try to do that. So we're going to say that the vector components, these are now components, and this should be an n, I'm writing so, components are going to be vy. So how do we find vy? Well, remember you have an angle, so you're going to say that sine of 60 degrees is going to be equal to vy. Remember, it's going to be the opposite side, okay? Alpha opposite is going to be v, and in this case 60 opposite is going to be vy over the hypotenuse, and in this case the hypotenuse, remember, is going to be the length of the vector, okay? Remember, the length of the vector, you write it like this. You have, if this is your magnitude, then you would say that, well, the absolute value, technically it's not the absolute value but you write it as if you were doing an absolute value. This is equal to 4 newtons, okay? This is how you represent the magnitude of a vector. And now, this is the hypotenuse, right? So we can just simply write down here the magnitude of the vector, okay? And this is going to be the angle that we're playing with. And so we're going to have that this is vy over how much is the magnitude of the vector? That's just going to be 4, okay? And this is all newtons, don't forget that. You can write here newtons. Now, how do you find vy? Well, that's simple. You're going to have that vy is equal to, you can move this 4 and multiply, 4 times sine of 60, okay? Newtons. Whatever this is, that is going to be vy. And now our little friend, the calculator, says that this is equal to 2 times square root 3, okay? And this is newtons, okay? Don't forget the units. Now this is basically what we just did right here. We're saying that vy, which is basically v in this right triangle, is equal to 2 times square root 3 newtons, okay? That's it. That is basically what we did. When you're finding vector components, you're just finding the sides of a right triangle. Now, what about the vector component x? So let's do it. Now we know we can use cosine and the angle. So we're going to have cosine. The angle is 60 degrees. So cosine of 60 degrees is going to be equal to the adjacent side, which we know is vx, over the hypotenuse, which is the length of the vector, which we write it like this. Okay? Now, if we plug in some values into this equation, then we would have that vx, naturally, just let me write vx over 4 in newtons, okay? And now how do we find vx? Well, we do the same thing. Vx is going to be equal to, just move this 4 and multiply right there, and you're going to have 4 times cosine of 60 degrees newtons, okay? And now if you use your calculator, you're going to find that this is equal to 2 newtons, okay? Now this is pretty good. Now, what do we have in here? Well, we just simply said that for this vector, for basically vector v, we're going to have a component, so you could say vector v is going to have a x component that is going to be 2 newtons, and a y component that is going to be 2 times square root 3 newtons. Okay, we just found the vector component for v. It's pretty simple. I hope you saw what we were doing is just basically finding the sides of a right triangle, okay? You have basically, you have the information that you need. You have a magnitude, the direction. Make sure that the angle that you have with respect to the x-axis is the direction that you're given, and then make a line that is that has a length of the magnitude of the vector, and then just find the both sides that you have, okay? This side, which let's say it's A, and this side, which let's say it's B, okay? And they are respectively Vx and Vy, okay? So these are the vector components for any vector that you want, okay? You can find them like this. So I hope you enjoyed this video, learned something. Don't forget to smash the like button, and see you in the following video.